While by solving this particular problem, we will be able to understand the concept of molarity and the molar mass. The question says that calculate the mass of CH3COONA, which is which is a sodium which is sodium acetate, sodium derivative of acetic acid. Acetic acid is CH3COOH, so it's sodium acetate. Required to make 500 milliliter of 0.375 molar aqueous solution. So you are given a task. You're going to make 500 ml of a solution whose concentration should be 0.375 molar, and the substance that you're going to put is sodium acetate, and you're going to calculate how much mass of this CH3COONA in gram is required to prepare 500 ml of the solution whose concentration should be this. So let's try to understand what does this concentration means. This means that 0.375 molar, it means that 1 liter of the solution contains 0.375 mole of CH3COONA. This should be the concentration that you're required to prepare. So that means 1 liter of the solution, of the aqueous solution of sodium acetate, should contain 0.375 mole of sodium acetate. That means in half a liter, because we're going to make half a liter. This is in one liter, but we're going to make half a liter of solution. So in half a liter, or 500 ml means half a liter. Half a liter will be half of it, which is 0.1875 mole. So in this 500 ml of solution that we're going to prepare, this much mole of the substance should be added. So, but mole is what? It's a number. 1 mole is Avogadro number, 6.022 into 10 to the power 23 molecules of sodium acetate, say. But this is not even 1 mole, it's 0.1875 mole. So 0.1875 multiplied by 6.022 into 10 to the power 23 molecules of sodium acetate is required. So you want now we will convert this mole into mass. How is the relation between the mole and mass? That is molar mass. The molar mass given, the question has given you the molar mass. You don't need to know the atomic mass of sodium, oxygen, carbon, and hydrogen. Although we know it, the carbon, even if they have not given this, we can calculate it if we know the atomic mass of the elements present. Suppose sodium is 23, oxygen is 16, carbon is 12, and hydrogen is 1. So we can easily calculate its molar mass. Still the question is given, so we will use this one, 82. Let's forget this one. What's behind it? What starts with after decimal? It's 82 gram per mole. That means 1 mole of sodium acetate weighs 82 gram. So obviously 0.1875, the amount that the number that you want, how much will be the mass of this multiplied by this. So it's around 15 gram. It's around 15 gram. So this is the final answer. So 15 gram of sodium acetate will be required. So when you mix 15 gram of sodium acetate in 500 ml of water, you get the solution, right? You get sodium acetate solution, and the concentration of that solution will be 0.375 moles per liter, molar, or 0.375 molarity. This will be the concentration of the solution. There's one more way to calculate this. You can use the relationship between the molarity, the number of moles, and the volume solution. It says that molarity, it means that number of moles of solid in 1 liter of solution. So the relationship is molarity is equal to N by V. And how do you calculate the number of moles? It's calculated by dividing the given mass by its molar mass. That will be the number of moles. So and what should be below it should be divided by the volume of the solution in liters. So in our case, the volume is given in milliliters, so convert it into liters, 0.5 liter. Then you know the molar mass it's given, and you need to calculate the weight, the mass, actual mass of substance required, and molarity is given. So in this equation, molarity, you know molarity, you know the molar mass, you know the volume. The only thing unknown is the mass of the substance that can be calculated, right? In this equation, four unknown quantities, four quantities are there, four variables there. 3 of them you know the values, so the unknown mass can be calculated. You can use this for this relationship also.